For about a month now, I've been assembling components and thinking about how to formulate a dual output tracking power supply. This is the schematic I think I'll use. I haven't breadboarded it yet. It uses an LM317 and its complement the LM337. And in order to facilitate construction of this, I intend to use this circuit board. Now this circuit board is sold to build a dual output servo amplifier. I have no idea what that means. I'll probably assemble about half of the components shown on this board. Then I intend to add a daughter board suspended over this area of the main board, the second floor, if you will. There are a couple of these boards available on eBay. Here's another one. It's a different form factor, uses virtually the same components, slightly different layout, but of the two, this one I thought was more acceptable for my ideas. I have done a schematic of both of these boards along with the parts list, as if you're going to develop them into what they are. And to keep things straight, when I use this board on a project, I'm referring it to the green board. And when I show this board, I refer to it as the blue board. Not to say that there aren't more on eBay. Here is the component layout and schematic of the green board. I need a new roller drum in my laser printer. This schematic was developed off of this board, as was this. Now, I've not constructed this, so I don't know, in fact, whether I've made some error or not. I'm including this schematic and layout, and I'll include a schematic and layout similar to this for the blue board. I'll include all of that in an informational subdirectory on my computer available to the public. If you do intend to pursue this, and you refer at times to this schematic, be aware that the board, when it's oriented so you can read the labels, is negative up here, positive down here. So the board here is exactly like that. Negative at the top, positive at the bottom. Output on the right hand, input on the left hand. The schematic is configured the same way. Negative up here, positive down here. I did a confusing thing. It's been confusing to me. The green board's laid out the same way. Well, this is the green board. All of the components here appear here. Only the components I'm intending to use appear here. Negative at the top, positive at the bottom. When I did the schematic, for some reason, I put the positive at the top and a negative at the bottom. So try not to confuse these two schematics, or just don't refer to this schematic. I'll give it to you, but you don't have to use it. What I've done is I've used the positive side pretty much. I added a reverse voltage diode, and I eliminated the components that define the servo board. And if it's in color, this green line represents a jumper that bypasses all of that stuff, which is all of this stuff. I did use 1/2 of the LF353. And that's the reason I picked these style of boards, is because the 8-pin layout is already there to accept an integrated circuit. On the green board, the integrated circuit was powered from the output, positive, negative. On the blue board, they actually powered it from the output, but they put some Zener diodes in to reduce the supply to the operational amplifier. On the green board, if you build it, this, whatever you choose as an output, will power at this total capacity the operational amplifier. On the blue board, if you choose to build it, there'll be some Zener diodes, and the power supply to the integrated circuit will be somewhat reduced. I decided to power the integrated circuit from the input using a 12-volt regulator. And complementary to that, on the negative power supply, I put a reverse voltage diode and a negative regulator. The purpose of these two regulators is twofold. Combined voltage, which will be 24 volts, supplies the integrated circuit, and I've included a fan connection so I can fan cool the heat sinks associated with these two 3x7 devices. This component will set the output voltage of the positive. Hopefully, this will sample the output voltage and adjust the negative to match, to suit, whatever you want to say. I did eliminate some components in the negative half of the supply, and the green line represents a jumper that bypassed them. All of the components in red are actually mounted on the daughter board, which, as I say, is suspended over top this section of the board. I'm going to go ahead off camera and populate the black components on this board. Now, on this tracking power supply, the components on the board are fairly straightforward. They're pretty much as marked. Something important. I'm going to put a dip socket in here. And the reason all this is black ink, I wanted to mark the used terminals while I was doing the work, so I could see what was unused. There was a method to that madness. Now I want to remove terminals 4 and 8 from this dip socket. Now, normally you can just pull them out the bottom. This is an almost molded socket, so I was able to pull out most of the dip socket. Most of the terminals, that is. What I intend to do now is lay it up on the edge here, get a little space under it, and push the remaining terminal out through the front of the socket, the upper side of the socket. There we go. Just like pulling a tooth. So now I have removed pins 4 and 8. The next thing I did that was sort of special, this board was laid out to use 1 amp diodes. This board was laid out to use a package bridge rectifier, even though this is not a bridge rectifier. And so the holes in this board will not accept a 3 amp diode. So I had to drill them out to 1/16 inch. Much bigger than a 16th is, I think, would be too big. If the wires are formed tightly against the body of the diode, the hole spacing works out well. Now, I had not intended, this board is laid out to accept little capacitors in parallel with each diode. They no longer can be used. But I didn't intend to use them anyway. So enlarge these holes or use 1 amp diodes. But if you use the 1N uh, 5400 series, the wire diameter is such it requires being drilled out. Almost all of the board mounted components are done here. There's some things I'll get to. You notice there's 2 missing pins. Alternately, I could have cut these two traces, one here and one here, that carry power to these pins. The jumpers are installed. Now these jumpers are shown green on both the board layout and the schematic. These 3 center terminals, I'll stick some wires in there to carry to an off-site voltage adjust potentiometer. These 3 components here and here, 6 in total, are not going to be installed. And the alternate case geometry for the 317 and the 337 were never going to be used. Eventually, in this hole, this hole, this hole, and this hole will be stuck and soldered some vertical wires that extend upward to a daughter board located up here somewhere. Right now, I'm toying around with heat sink sizes and locations. I believe this board was designed to be used with a heat sink like this. With either 1 locating pin or perhaps 2 locating pins, here and here. This is pretty small. I would like to use a fan. So I could mount something like this. But if I'm going to use this, I might as well use this. And I thought I could adapt something like this, but nothing seems to lend itself. Perhaps this. I think I could put 1 or 2 holes in the heatsink, just tap them, put a ring terminal or spade terminal, crimp them to a piece of stiff wire, and solder it here, or one, to fix this sink. Of course, then the 3 terminal device, I hope the legs would be long enough to bend it back to mount it here. If the legs don't fit, I might as well mount this thing else just off somewhere off site. I have enough done because I won't need the operational amplifier. I don't think I'll need the daughter board, so that if I hook up this potentiometer, I can power up and make adjustable the positive side of the board. And that's what I'll do next.